Okay, so for finding the indefinite integral, we have to remember what the simple power rule stated and what the general power rule was. So the simple power rule, you have the integral of a to the n dA. Then the antiderivative is a to the n plus 1 all over n plus 1 plus some constant c. So when I'm looking here at the integral of negative 5, that's going to give us negative 5 x to the 1 over 1 over 1 plus c. So we can just write that as negative 5x plus c. When there's nothing here, there's an invisible 1. So then this is going to be x to the first over 1 plus c. Now with 3x, we're going to rewrite this as 3 times the integral of x dx, which then is 3x squared over 2 plus c, and we can write that nicer as 3 halves x squared plus c. I'm going to rewrite 4 as well before I start to find the antiderivative. Instead of 1 over x to the third, if we write that as x to the negative third. So negative 3 plus 1 is negative 2. So I'm going to rewrite this as negative 1 half x to the negative 2 plus c, but I don't like that negative exponent. So I'm going to move that to the denominator, and here's our final answer. So again, with 5, I'm going to rewrite the radical as an exponent. Then 1 half plus 1 is 3 halves. But now, to eliminate the fraction in the denominator, we can multiply by its reciprocal. And our antiderivative is 2/3 x to the 3 halves plus c. Okay, so for number 6, because it's a polynomial, we can separate this into 3 different integrals. And then from here I can pull that constant away. Same thing with this 5. So now my antiderivative is 3x to the 5th over 5, and 5x to the 3rd over 3. This will be x squared over 2, all plus c. So then, cleaning this up to make it look better, this is going to be 3/5 x to the 5th minus 5/3 x to the 3rd plus 1 half x squared plus c. Now for number 7, we have to use the general power rule. So looking at the 3x minus 1 to the 4th, I'm going to let u equal 3x minus 1. So that means du dx is 3. So if I reorganize my integral here, if I solve for du, that equals 3 dx. So I can substitute for 3 dx the du, and instead of 3x minus 1, I make that u to the 4th. So now taking the antiderivative, That's u to the fifth over 5 plus c, but u is 3x minus 1. We could rewrite this as 1/5 3x minus 1 to the fifth plus c. Either one of these forms would be correct. Okay, we're going to do the same thing for number 8 here. Comparing these two factors, if I take the derivative of x squared, I get the 2x. So I'm going to choose u to be x squared plus x. So that means the derivative du dx is 2x plus 1, which we have here. So that means du equals 2x plus 1 times dx. Multiply both sides of this by dx. So reorganizing my integral, we have u du. So instead of x squared plus x, I substituted in u, and 2x plus 1 dx, I substituted in du. So now finding the integral, or the antiderivative, and then I'm going to substitute back in for u. And we can rewrite that as 1/2 x squared plus x squared plus c. Now for number 9, before I go any further, I'm going to change my fraction so that it is no longer the denominator. I'd rather that negative exponent. So looking at my two terms, if I make 1 minus 2x squared u, that means du dx is negative 4x, which is what we have here. So my integral can be rewritten as u to the negative 2 du. Because if I solve this for du, negative 4 times dx, so negative 4x dx is my du. Now finding the antiderivative, and I'm going to substitute back in for u. I'm going to clean this up. The negative exponent means move it to the denominator. The fraction's negative plus c. Okay, and last but not least, number 10. I'm going to set u to equal 3 minus 4x squared. So du dx is negative 8x. I notice I only have the x here. So let's reorganize this. So I need this term to read as x dx for my substitution. So first I will multiply both sides by the dx, and then I'm going to divide by the negative 8. So when I substitute in, this is u, so here's my u squared. Now x dx is du over negative 8. Well, I'm going to reorganize this. I can make this a constant, which then goes goes to the front of the integral. Now I'm going to take my antiderivative and simplify. Negative 1/8 times the third here is negative 1/24. U is 3 minus 4x squared to the third plus c. Okay, so now for the classwork and homework problems, there's 10 more to practice with. Going to change this so that I don't have the fraction. Use the simple power rule and reorganize that. Again, here I'm going to change it to a power. So then 1/3 plus 1 is 4/3. So I have x to the 4/3 over 4/3 plus c. But to rewrite this so it looks better, I'm going to multiply by the reciprocal of the denominator. Now for number 3, we have to be careful with our variable. There's a 1 here, but we're finding the antiderivative with respect to u. So that means I'm going to get u to the first over 1 plus c. Okay, so for number 4, we can individually write this so that it is the polynomial is split up. So then this piece is 4x to the 4th over 4 minus 5x squared over 2 plus 2x over 1 plus c. So to simplify, those 4's cancel to 1. Minus 5/2 x squared plus 2x plus c. Okay, because number 5 is a product of two different factors, looking at each term, I see that 3x squared is the derivative of x to the third. So I want u to be x to the third plus 6x, which means du dx is 3x squared plus 6. So when I multiply both sides by dx, I'm going to reorganize my integral. And I can substitute. This is du. Here I have u squared. So now finding the antiderivative and plugging back in for u. Okay, number 6 works the same way. I'm going to let u be the 3x to the 4th plus 1, because then du dx is 12x to the 3rd. Well, I notice I have x to the 3rd dx. So I'm going to solve this for x to the 3rd dx, which is du over 12. So for my integral, I have u squared du over 12. that my 1/12 is a coefficient, because then that can come to the front. Finding my antiderivative, raising the power by 1 over n plus 1. And now simplifying, 12 times 3 is 1/36. Substituting back in for u, plus c. Number 7 I'm going to rewrite as x squared plus 1 to the 1/2 5x dx. So I'm going to let u equal x squared plus 1, which means du over dx is 2x. Well, here we have 5x dx. So if I solve this for x dx, I can substitute in for this piece. So we have the integral of u to the 1/2 5 times du over 2. So rewriting that, that's 5/2 u to the 1/2 du. So finding my antiderivative, I'm going to multiply by the reciprocal. And 5/2 times 2/3, well, that's 10 over 6. Substitute back in for u. But then 10/6 can reduce to 5/3. So our final answer is 5/3 x squared plus 1 to the 3/2 plus c. Now for number 8, because I still have a term to a binomial to a power, I'm going to let u equal x minus 1. So that means du dx is 1, which means du equals dx. So rewriting my integral, I have u to the 5th over 5 plus c, which is 1/5 of x minus 1 to the 5th plus c. Number 9 we have to rewrite so that we don't have the fraction. Then I'm going to choose u to be 1 plus x to the 3rd, which means du over dx is 3x squared. Well, I have an x squared dx here. So once I multiply the dx to this side, if I divide by 3, I have the term that I need to substitute for. Rewrite the divided by 3 as a 1/3. And we're going to simplify here. The negative exponent means move to the bottom. And then negative 1 times the 3rd is the negative 1/3. And substitute back in my u for the u term. And last but not least, we have number 10. I'm going to let u equal x squared minus 1. So that means du dx is 2x. So du equals 2x dx. But I notice here I'm just going to have an x dx. So du over 2 is x dx. So rewriting my integral, I'm going to pull out that 1/2, take the antiderivative, combine my fractions, substitute back in for u, and there we have it.